So I'm looking at question 12. And question 12 says something about Pat has 30 meters of fencing to enclose 3, and the key word is identical stalls. Now, what about identical stalls behind the barn? And here's a picture. So it says what dimensions will produce a maximum area for each stall. So let's give everything a name. What dimensions? So that's X, and all the stalls are, what's going on? All the stalls are pretty much the same. That's Y, that's Y. We'll just give it a value. That's going to be X, X times Y, X times Y, X times Y, you know? And then I'll make them the same dimensions. Okay, so what are the restrictions? What is the restrictions? Well, all of this fencing is going to be 30 meters. So, can I write a relationship between X and Y? And what dimensions will produce the maximum area for each stall? Well, the area, we can rewrite area. Actually, let's work below. And let's recreate the question just down here. And I'll say something like, I have this. Oops. What's going to be fenced is the following. We're going to fence this. We're going to fence that. And then I have, whoops. Anyway, something like that. And that's X, 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 so fencing Y, Y, and Y. And all this fencing, all 4 X's, and these 3Y, 1, 2, 3, plus 3Y, it's going to equal to, let's see the question, 30 meters. And now I have to say that the area, I'm going to have an area. So let A of X represent the area, the area of the fenced area. I should say the fenced area. Let's change this to object eraser. The fenced, area for length X. So I'm just going to write that there. So A of X is actually equal to, well, it's equal to X multiplied by 3Y. Now, I need it in terms of X, but I have a Y here. But luckily, I have this here too. I can write Y in terms of X. So I can isolate for Y. Why do I do that? Because I only want one variable. And I can rewrite, I can replace this Y with some value. So let's rewrite it. 3Y equals 30 minus 4X. And Y is equal to 30 minus 4X over 3. Which means Y is equal to, and now we're talking about 30 over 3 minus 4x over 3. Y is equal to, oh, why is my pen writing weird? Y is equal to 10 minus 4x over 3. So guess what I can do? I can replace this, or I can substitute this into this Y right there. So let's do that. A of X equals X times 3 times whatever Y is, 10 minus 4x over 3. What's happening? Okay, so let's rewrite it. Now I have A of X in terms of X only, no Y's. So now, let's see what I get. Let's simplify, or let's expand. 3x times 10 minus 4x over 3. Now we're going to multiply what are we going to do? We're going to multiply 3x times 10 and 3x times 4x over 3. A of x is equal to 3x times 10 minus 3x times 4x over 3. That leaves me with A of x equals 30x minus 4x squared. We cross out the 3 because 3 divided by 3 is 1. So what are we left with? Okay, we have A of x equals 30, or sorry, let's rearrange it. Minus 4x squared plus 30x. Okay, so what does it say? What dimensions will produce a maximum area for each stall? All right, so if you notice, I can do partial factoring. This is actually, it's going to look like this if you recognize it from previous exercises, because I don't have, right? Because at x equals 0, that'll be 0, and that'll be 0. So A of x will be 0. And of course, if my dimensions of x is 0, then I'll have no area. So obviously, it's going to cross somewhere there. So let's go ahead and find the zeros. Why? So we can find the maximum is going to occur at x equals whatever the midpoint between the zeros are. So what do? We take out, let's see. Let's take out minus 4x, minus 4x. What do we end up getting? We get x minus 30 over 4x. Right? So that means this is equal, at the zeros, at A of x, when area equals 0, at the zeros, that equals 0, minus 4x equals 0, which means x equals 0, or x minus 30, oops, we don't have 30 over 4. Let's do this again. X minus 30 over 4, x minus 30 over 4 is equal to 0. So x is actually equal to, 30 over 4 actually turns out to be, well, let's just write 30 over, oh my God. It turns out to be 30 over 4 positive, which is equal to 15 over 2, which is equal to 7.5, which means if x is between 0, 7.5, then what's this going to be? It's going to be 3.75. It's going to be 0 plus 7.5 over 2. And that's equal to 7.5 over 2, which is equal to 3.75. So the dimensions, x is actually going to be, x is actually going to be equal to 3.75. And y is going to be given by this over here. 10 minus 4 over 3x. 10 minus 4 over 3x. And what does that mean? Well, when x is 3.75, y is equal to 10, take away, 3.75 times 4. Let's just put it in our calculator. So we have, let's do the math right now. 3.75 times 4 equals 15 divided by 3 is 5, and y is equal to 10 minus 5, which is equal to 5. So the dimensions is going to be, 5, right? 5, 5, and these are going to be 3.75 each. That will give us the maximum area. Okay, so what does that mean? So 3.75 times 4 is 15, right? 4 of these is equal to 15, and 5 of these is equal to 15, so a total of 30. That makes sense. So what is the maximum area? Well, the maximum area is when 3.75 is there, so it's 3.75 times 15. And if I put that into a calculator, the maximum area is 56.25. And that's how you